Okay, our first pair is Terry Fairbanks from the Bureau of Land Management and Emilie Henderson, who's with the Institute for Natural Resources. They'll be talking about finding a common language, building science to match forest planning needs in Southwest Oregon. Take it away.
Hi, I'm Terry Fairbanks, and I work for the Bureau of Land Management. And yes, managers dance. We do a... Lift this up. And this is your... Thank you. Is that better? Yeah, much better. Okay. Yes, we do a lot of dancing. I will have to admit, maybe not in the way that you think. And there are a lot of stars out there, you know, thousands and thousands of them in the sky. I worked with Emilie Henderson on a project that was pretty important to BLM. There are kind of two phases to the project. And the first one, I briefly want to tell you about it and give you a little background, but I want to leave plenty of time for Emilie to talk about the project. So, yeah. No, not that one. Pointer. Oh, right. Okay, great. Thanks. Arrows. The Bureau of Land Management is in the process of revising their resource management plan. The goal here is the BLM districts. The place where we're revising our management plan is Western Oregon. They're in the magenta. And Western Oregon, basically, 2.5 million acres. And then Medford District, which is where I work, in Southwest Oregon. And so when we started revising our plan, we needed to be able to use potential vegetation types. And there were efforts out there, but none of them were really continuous. And then I met the ILAP, the Integrated Resource Group, and they had a map that was continuous potential vegetation types. And so the reason we needed those in order to revise our plan was because we wanted to be able to distinguish between dry and moist forests. Our management was going to differ by those two. So I worked with Emilie. We needed some revisions to the Southwest Oregon map, and we worked by telephone, we worked by GoToMeeting. We didn't even know each other when we first came here. I had seen her once, but she'd never seen me because I was in the audience. So the first part was getting this map, and then the second one was a process of looking at restoration where she interviewed me. So the first project, she was providing some products that we needed. And I just wanted to briefly say, okay, why would it be important to know vegetation types? Particularly when you're revising your whole resource management plan. Well, if productivity and sustainability are going to change, we really need to know how much, where, and how. If disturbance patterns are going to change, we need to know how much, where, and to what extent. And then, of course, threatened and endangered species habitat. That's a big part of our mission, is a lot of documents driving our behavior. So we really need to know these things. And distinguishing between dry and moist is much more complicated, this map, but I wanted to show you how we ended up having to reduce all of these potential vegetation types into dry forest and moist forest. The yellow is, for Southwest Oregon, is the dry forest, about 90% of it. And the rest of it is the moist. And why dry forest? Why does that make a difference? Well, we have different prescriptions for managing the forest based on dry forests where fires are really frequent, historical. I mean, like 10 to 15 years. And they really are at risk after 70 years of fire suppression, of a real uncharacteristic fire. And we can't just leave them alone to grow, or we'll lose all the structure in the forest. So restoration, active management, some thinning, some uneven age management, some prescribed burning is what we think for restoration. So the one other project that I worked with Emilie on is she interviewed me about restoration. And I was able to provide some land knowledge to her and to help her on that. That should give you the background. She'll tell you about the project. Good catch.
Alrighty, so I'm going to step back to these potential vegetation types, because this was, to use Goose's analogy, this was kind of the dance floor which we used for the rest of the project. Or Another analogy I like is this was really our common language. It was kind of our common ground to begin with. Terry needed this information to figure out, well, where are the dry and moist forests currently? At that stage, we've got a starting point to ask, well, where would they be in the future? And I needed this information in a well-tuned fashion for the foundation for my research, which Terry helped me out with immensely. And the nice thing about having worked together to build this map is that when I talk about Terry, I need some help understanding silvicultural management as the BLM might like to see it in the dry Douglas fir forest. We're actually talking about the same thing. It's quite nice. And then for my end of things, that's those, on Terry's end of things, they're tied to a suite of forest dynamics which she understands and knowledge about how she might like to manage those forests as silviculturists. On my end, it's tied to a suite of models that I actually got originally from the Forest Service. They're relatively straightforward models. You don't need to be a rocket scientist or a physicist to understand how these work. They're state and transition models. And I've basically got one per color in this map. So, right now I've got some arrows showing how the models link up with that map. So this is really, that map, starting with a realistic and solid foundation, was just crucial for building something which is going to be actually useful to Terry as we move forwards. So for those of you who are not modeling geeks, I want to point out some things about state and transition modeling, mostly because it explains why there's such a useful vehicle to use in these conversations with people like Terry. It's a relatively straightforward way to look at the world. You divide it up into boxes. You use those boxes to describe how you might expect forests to change through time. You might have young forests transitioning to old forests. You hitch those boxes up with transitions. Pretty straightforward. You might have growth, you might have fire, you might have regeneration, harvest, or other flavors of silviculture wired in there as well. And you could track, say, a suite of stands in a landscape through time. Through these models, you let them bounce around, and you get the idea. The nice thing is when you get to the end of this, you can start looking at those boxes and say, hey, look, at the end of our modeling simulation, we've got tons of owl habitat in that old growth forest. That's great, but maybe we should worry about fire. So it's a way to sort of hitch those management things up with forest dynamics and start to ask questions about how do we think these things might play out along the landscape. And conversations with Terry were really crucial in terms of asking those questions clearly within the framework of parameterizing this model. I can't emphasize enough that Terry's feedback in terms of figuring out what those prescriptions were for the dry forests and the moist forests her feedback was absolutely crucial. And it got us to the point where we could start asking that question of, can these strategies, which the BLM's considering in the two forests, could they work under climate change? Now, there's a couple of other things which we needed to address before we could get at that question. And unfortunately, Terry couldn't answer all of those questions for me. The first one is, of course, how will this map change? And in order to answer that question, I had to turn to another model, which is, I'll be very brief with this. It's a dynamic global vegetation model called MC2. There are people in this audience who could tell you more about the inner workings of that model. Suffice to say, it's a way to hitch information from the GCMs, the global climate models, up with an estimation of what the landscape might look like. Integrates a bunch of information, provides some output that describes how biogeography and fire regimes might change through time in different climate contexts. So to answer that question, I'm just going to show you results from one climate scenario. It's a Hadley RCP 8.5. This is a very hot and dry scenario. So this is kind of a worst case scenario. I figure it's useful for here. And we can see through time, yes, that landscape changes. I'll go back and again. In fact, it may change quite dramatically by the end of our hot and dry scenario. Well, that's useful information in and of itself. This is not yet in a form which is necessarily directly relevant to Terry. One of the things that you might notice is that the colors are different in this map than they were in the first one. And that's because MC2 effectively speaks a different language. It has different vegetation types. We had to do some translation, but we did it to translate the information from MC2 on biogeography over to those potential vegetation types. And we also pulled some information with respect to how fire regimes might behave out of that model. Put it together in one really big state and transition model with everything eventually wired together. The state and transition models providing us information on how forest growth might work, insects, pathogens, wind, silviculture, and MC2 providing some information on how potential vegetation types might change. You can see there are clusters of boxes. Those are the original state transition models, which are wired together now. And also information on how that fire weather might change through time. And we effectively put these, very carefully put these things together, and I will spare you the details. We didn't actually use duct tape. And I'll move on to some early results. And there's good news and bad news in this graph for Terry. The good news is I think we did a pretty good job describing what restoration might look like on the BLM's general forest lands. So this is just a summary of a subset of the southwestern Oregon landscape. There's prescribed fire going on, there's partial harvest going on. You'll notice prescribed fire kind of ramps up in the beginning and takes over some of the partial harvest. Those are essentially fuel treatments in the dry forest. BLM has a lot of them. There's a smidgen of regeneration harvest in there, and that's kind of the management part of this. There's another good piece of good news in this graph, and that's that the owl habitat, it's that green line in the middle. I hope you can see it okay. It bounces up and down a little bit, around about 40% of their landscape. So owl habitat does not plummet in our scenario, which is good. You've probably already seen the bad news in this graph, however, and that's that the amount which is getting treated every year is kind of there's a lot of fire-prone forests on the landscape, and with the probability of fire ramping up every year, as far as we can tell, fire is going to be a very real part of this landscape, and it's going to become a greater problem as we go forward, assuming that the worst-case scenario, climate scenario, plays out. So that was the bad news, that, well, fire still seems to ramp up, even though we are treating a good portion of the landscape. But the good news, which is still behind this graph, is that my models, those models, are not perfect. One of the things which I can't show in the current modeling paradigm is the effect of strategy. So the BLM is probably not going to place fuel treatments willy-nilly all over the landscape. They're going to be strategic about it. They know that they can't treat all the acres which need to be treated. If fuels are removed in strategic points within a watershed, then perhaps fire spread can be curtailed, and those catastrophes also will be better curtailed in the future if we have some strategy. I don't show the effects of that strategy, so the future may turn out better than this indicates, which is a good thing. There's reason to hope that we're not doomed. So one of the other nice things about the modeling scheme which we can do is we can provide Terry with a bit of broader perspective. And right here I'm showing some of the owl habitat output of those models, so what percentage of the landscape turned up in those boxes which we thought the owls would like. And this is a patchwork of modeling results. So as we go forward, I want you to watch the upper right-hand, sort of the northeastern corner. That's actually kind of up near Crater Lake. There's a lot of white fir forest in that area. So watch that dark green blob in the upper right-hand corner, and watch the light blob in the southwestern corner, which is the very southwestern corner of Oregon near the ocean. So watch those two blobs. I'll go forward. Cool. Upper right one kind of fades out a little bit, and that lower left bit gets a lot darker. Well, that's interesting. So it doesn't really look like, whoops, the total amount of owl habitat's changing, but when you look at this broad scale, but maybe we should be looking ahead strategically about which areas are most likely to grow owl habitat in the future. So one of the things which is driving this is in that upper right-hand corner, the white fir forests are very fire prone. And the fire handling which is going on in my state and transition models, there's a lot of fire in there. Most of the owl habitat loss is due to fire, which is consistent what folks have seen, say, in the Northwest Forest Plan effectiveness monitoring. Most of the owl habitat loss in southwestern Oregon is due to fire. But the good news in this is that, well, Those forests which are younger, a little closer to the Coast Range, they're actually poised at around about 2050. They may be old enough and have a structure which may provide some new owl habitat to replace that. So I'm going to end on that note, that hopeful note, with the caveat that there are numerous ways in which things which are missing in this model, things which I might be goofing up, there may be surprises with respect to fire in the Coast Range. There are caveats, but nonetheless, it's a useful story. And with that, I'm going to pass the baton off to Terry so that she can say a little bit more about where this story might go next.
I want to bring it back to the partnership and the relationship and try to share a little bit of what I'm hoping some of you can take as some ideas for management partnerships. Affecting policy and strategic planning, I think there are several ways to do that, and the universities are very adept at entering into agreements with the agencies, and sometimes it's just project specific, but sometimes it's broader, and sometimes it's kind of like a cooperative where you provide a certain amount or a certain kind of information over time. So those are ongoing, but you continue to develop those. Collaboration, like we're doing today, and being here, and Emilie was just so adept at interviewing me, just an information interview, and trying for me to explain what I knew about the landscape down there in Southern Oregon. The reciprocal learning, certainly we have a lot to learn, and the Forest Service has been great, I think, about training and climate change, and BLM, I think, is beginning to get there, but just participating in that basic learning is certainly important. And then, of course, the whole idea of speaking different languages and being able to take the time to find out what you're trying to say, what they're trying to say, and seeing if you mean the same thing. And then one last thing is adaptive management. Managers don't like uncertainty and risk, and yet that's one of our jobs, is to manage it. So we're going to hesitate. We're going to be recalcitrant until we have some sort of sense of direction. And so to the degree that researchers can help us with that, bracket that uncertainty and risk, you're going to get managers on board and have them looking towards the future. So, and then again, just quantitative and qualitative models are immensely helpful. Our models we use in the agencies are usually data-rich and kind of local specific, but there's a place for other kinds of models as well in terms of informing us. So Emilie, you had some future steps as well, didn't you? Oh, okay.
Make a lot of acknowledgments, however. This was a project which was building off of a lot of other efforts.
Oh, sorry, we can. Thank you so much. That was really interesting.